Welcome back to the Before AGI podcast. Today we're taking a deep dive into a really cool area of AI, synthetic data.
Yeah, you got it. It's pretty fascinating stuff. And, for our listeners who are all about getting a handle on important tech concepts without, getting lost in all the crazy technical details, I think we've got a lot to cover today. We're going to break down exactly what synthetic data is, why it's such a hot topic right now, and how it's changing the whole AI world.
For sure. Think of it like a crash course on a really crucial concept in AI today. We'll explore how this artificial data is actually being used to solve some pretty challenging real-world problems. And maybe even more importantly, how it's opening up some wild new possibilities. I guess to kick things off, let's just start with the basics. What exactly is synthetic data?
Well, simply put, synthetic data is data that's artificially created, generated by computer programs. But the key here, the thing that really matters, is that it's designed to mirror the statistical characteristics of real-world data. So basically, it looks and acts like the real deal, but it doesn't actually contain any real sensitive information from the original sources.
Oh, that's interesting. That makes it sound incredibly useful. Why is this becoming such a big deal in AI?
I think it's becoming so important because it tackles head-on some really tricky issues that we have with real data. Think about it. Privacy, right? Huge concern these days. And real data, it can be hard to come by in a lot of areas, and often it comes with its own biases baked in. And getting and labeling huge amounts of real data, it's a pain. It can cost a ton of money and takes forever. Synthetic data offers a clever workaround for a lot of these problems.
So you're saying instead of spending ages hunting for real data or worrying about privacy rules, we can basically just, create our own data a year?
That's exactly it. And the impact of that, well, it's potentially massive. Gartner, for example, they're predicting that by 2024, a whopping 60% of the data used to train AI models will be synthetic. That's a total game changer for how AI is developed.
60% by next year. That is huge. Okay, so this is where it starts to get really interesting. What kinds of synthetic data are we talking about here? Is it all just, numbers in a spreadsheet?
No, not at all. We typically see two main flavors of synthetic data. There's structured data, which is, as you said, your classic organized stuff like in tables and databases. And then you've got unstructured data. That's more like images and videos. Both have their uses, of course, but I think the structured synthetic data, that's what's proving really valuable for businesses doing analytics and for training all sorts of machine learning models.
So say a company wants to create an AI that predicts, I don't know, which customers might unsubscribe from their service or something. Could they use synthetic data to mimic their customer records for that?
Exactly. That's a perfect example. And it's worth understanding the difference, too, between fully synthetic data and partially synthetic data. The fully synthetic stuff, that's generated completely from scratch. No original data involved at all. But partially synthetic data, that might start with some real data, but then any sensitive bits, like names or addresses, are swapped out for artificial data. It gives you a lot of flexibility depending on what you need it for, and how much privacy you need to maintain.
Okay, so we get what it is and why it's such a big deal, but how is synthetic data actually made? It all sounds pretty high-tech.
Oh, it can be. Especially some of the newer, more advanced techniques. A lot of the really cutting-edge methods, those fall under what we call generative AI.
Generative AI, right. That's the tech behind all those crazy AI image generators that have been blowing up lately, right?
That's the one. And those same principles are being used to create synthetic data. One major approach is using these things called GANs, Generative Adversarial Networks. They were originally created by, it was Ian Goodfellow who first came up with the idea. Basically, imagine you have two AI models going head-to-head. One's the generator, is trying to create fake data, and then the other, the discriminator, is trying to spot the fakes. And this constant back and forth, this competition, forces the generator to get super good at making really, really convincing synthetic data. Research even suggests GANs have, and I quote, vast applicability in model training to generate realistic, highly detailed representations.
Wow. That's a wild approach, like a constant AI battle leading to better and better results. What are some other ways synthetic data is made?
Well, another really powerful method uses something called Variational Autoencoders, or VAEs for short. Think of them like pairs of neural networks. You've got the encoder. It learns to represent real data in a kind of compressed form, capturing the essential features. And then the decoder, it takes that compressed representation and uses it to create new synthetic data points that share those features. VAEs are particularly good at figuring out and replicating the overall patterns in the data. It's kind of like, I don't know, an artist learning the key elements of a particular style and then using that to create new artwork in that style.
So they learn the underlying structure, the essence of the data, and then they make new examples that fit that structure.
Very cool. Do these transformer-based models, the ones behind those advanced language AIs, do they play a role here as well? Absolutely. Think about the tech behind things like OpenAI's GPT, right? These transformer-based AI models are amazing at picking up patterns in data, especially in sequences like text. But they're not limited to just language. They can also learn the statistical patterns in structured data and then generate synthetic versions of it. As one of our sources puts it, they excel at capturing the patterns that exist in data.
So we've got generative AI, clearly a major player in creating synthetic data. Are there some more basic, more traditional methods too?
Oh yeah, for sure. One really straightforward approach is what we call rules-based generation. It's all about creating artificial data based on rules and policies that the user sets. So for instance, if you know certain relationships have to exist in your data, you can program those rules into the system to generate synthetic data that follows those rules. It gives you a lot of control, and it's great for incorporating specific business logic into your data.
Sounds pretty practical for certain situations. What about when you've got some real data, but you need to, protect the private info within it? How do you handle that?
Well, that's where techniques like entity cloning and data masking come in handy. With entity cloning, you take all the data linked to a specific entity. Let's say a customer, right?
Yeah.
You grab all their info, then replace any sensitive stuff like their name or address with synthetic values, and then you create multiple new, totally artificial customer profiles based on that template. That way you keep all the relationships between the different pieces of customer data, but without revealing any real personal information.
So, like, the connections between a customer's purchases, their demographics, all that would be preserved in the synthetic data.
Exactly.
Yeah.
Data masking takes a slightly different approach. It focuses on hiding personally identifiable information, things like social security numbers, credit card details, phone numbers, all that, within an existing data set. The idea is to create data sets that are safe to use because all the sensitive values have been changed or masked, but the overall structure and the general statistical properties of the data, those stay the same. It's super useful when you need to keep the original data format, but of course you've got to ensure privacy.
Okay, this is all really fascinating, but why should our listeners care about this? What are the real-world applications that make this such an important concept to grasp?
Well, as we've touched on, a big one is training AI and machine learning models. Synthetic data is a lifesaver when real data is either scarce or too sensitive to use directly, or just too darn expensive to collect and label. As Y Data points out, synthetic data can enhance ML performance because it gives you a much larger and more varied set of examples, but they still reflect the patterns of real data. This is super helpful for dealing with things like imbalanced data sets, where you might only have a few examples of a particular outcome that you're trying to predict, or if you're trying to understand rare events.
So if you were building an AI to detect some super rare type of equipment failure, synthetic data could give you the examples you need to actually train the model effectively.
You got it. Spot on. Another key application is in software testing and development. When you're building new software, you need to test it thoroughly, right? And you need to do that with all sorts of different data scenarios. But using real customer data for testing, that's a huge privacy risk. Synthetic data lets you test your software at scale without that risk. Plus, you can actually create specific edge cases, those unusual or extreme scenarios that might not happen very often in real life, but are critical for making sure your software can handle anything you throw at it. There are tools out there, like Synth, which are specifically designed to, and I quote, create realistic data to your specifications and develop test data for your applications. K2View, another company, they emphasize the fast data generation that's possible with synthetic data, and that can really speed up development and cut costs.
That makes a lot of sense, testing with artificial data that can mimic pretty much any situation. What about the whole increasing focus on data privacy and regulatory compliance?
Yeah, that's another big win for synthetic data. With all these regulations, things like GDPR, IPA, CCPA, they're getting stricter all the time. Companies need ways to work with data responsibly. By swapping out sensitive data with these synthetic alternatives, companies can innovate. They can analyze data, train their models, all without breaking any privacy laws. In healthcare, for example, it's absolutely crucial to protect patient data, but they also need to do things like improve clinical trials. Synthetic data can help overcome the limitations imposed by regulations like HIPAA by enabling the creation of AI-generated data that, while not real patient information, retains the same statistical relevance.
So medical researchers could potentially train their AIs on synthetic patient data, discover new treatments without ever needing to access real patient records.
Exactly. And then there's the whole issue of data scarcity and imbalance. We talked about rare events, but it also applies to situations where real data just doesn't cover every scenario you need. A great example is self-driving cars. Those vehicles need to learn how to handle a crazy variety of traffic situations, many of which just don't happen that often in real life. In cases like that, synthetic data can fill in the gaps and create a much richer data set for AI training, and ultimately that can lead to safer, more reliable self-driving systems.
Okay, this is clearly a really versatile and powerful tool for anyone who wants to try using synthetic data. What kind of resources or tools are out there?
Oh, there's a whole growing ecosystem of tools out there, everything from all-in-one commercial platforms that handle everything to more flexible open source options, plus some specialized tools that are focused on specific data types or use cases.
Let's start with the commercial platforms. Who are some of the big names in that space?
Some of the big players are companies like Mostly AI, Synthesize.io, K2View, and YData. Synthesize.io, they describe themselves as a generative AI-powered synthetic data generator. It's really good for creating realistic test data, while still protecting privacy. They also talk a lot about how it can be integrated with systems like Kubernetes for efficient data management. K2View, they've got an AI-powered synthetic data generation tool that's all about managing the entire life cycle of synthetic data, from connecting to your source systems to generating and deploying your synthetic data sets. And then you've got YData. They've got a platform that supports a bunch of different data types, which makes it applicable to a lot of different industries like healthcare, finance, and e-commerce.
So these are the more comprehensive options for, I guess, bigger companies, right? What about individual developers or, smaller teams who just want to play around with synthetic data?
Ah, well, that's where the open source tools come in. These are awesome because they're usually free to use and they're super flexible. One popular option is Synth. It's described as a data generator that helps you create realistic data. And it works with both SQL and NoSQL databases, all using a pretty simple configuration setup. Another cool open source project is sdv.dev, which stands for Synthetic Data Vault. That one's a more comprehensive platform that's specifically designed for generating high-quality synthetic data for things like machine learning and data science. It even includes a whole bunch of different synthetic data generation models like CTGAN and TimeGAN that are optimized for different types of data. And then there's Doppelganger, which is specifically for generating synthetic time series data, which is crucial for applications like financial modeling or sensor data analysis.
Wow, it sounds like there are options for just about every need and skill level. You mentioned specialized solutions too.
Oh yeah, definitely. There are a bunch of tools that are specifically made for very particular data types or, for very specific use cases. Some examples our research found were Gradle Workflows, Tofu, Twinify, Datadynamic, and Benerator. These tools might be designed for, let's say, generating synthetic genomic data for research or creating super specific types of test data for certain software or all sorts of other niche areas.
So we've got this growing toolbox for creating and using synthetic data. What are the overall advantages of using this technology, and are there any gotchas, anything we should be careful about?
Well, the benefits are pretty huge, as we've discussed. Privacy protection, regulatory compliance, those are big ones. But synthetic data is also incredibly scalable, meaning you can generate basically unlimited amounts of data whenever you need it. It's customizable, so you can create those edge cases that make your testing and models more robust. And as we said, it can actually lead to better AI performance because it gives you more balanced, more representative training data sets. K2View, they really stress how fast the generation process is, which is a huge advantage for teams working on tight deadlines.
Okay, those are some really compelling advantages, but are there any potential downsides? Are there any challenges with using synthetic data?
Well, like with anything, there are things to keep in mind. The quality of your synthetic data, that's totally dependent on the method you use to generate it, and also on the quality of any real data it's based on. You have to make sure the synthetic data truly reflects the statistical properties of the real-world data it's supposed to mimic. Also, some of the more advanced techniques for generating synthetic data can be pretty complex to implement. They require some specific expertise.
So a powerful tool, but one that needs to be used carefully and with a good understanding of how it all works. Looking ahead, what's in store for synthetic data? Is this just a fad, or is it a real fundamental shift?
Oh, this is definitely a fundamental shift. Everything points to synthetic data becoming more and more essential in the worlds of AI and data. Gartner's prediction of 60% adoption by 2024 is a pretty strong indicator of that. Understanding synthetic data now isn't just about keeping up with the latest trends, it's about getting a glimpse into the future of AI. Being able to generate high-quality, privacy-protected data on demand, that's going to be a must-have for companies in all kinds of industries.
So as we've seen today, synthetic data is a powerful and rapidly evolving area with the potential to completely change how we approach AI development. It offers solutions to some really tough challenges around data privacy, availability, and bias. It's definitely a key concept for anyone who wants to understand where AI is heading.
We hope this deep dive has given you a clear and engaging overview, but there's always more to learn, from the details of specific generation techniques to the ever-growing list of applications. This is where it gets really interesting.
What stands out to you about the potential of synthetic data? What questions does this raise for you about the future of AI and data? Think about this. As AI becomes more woven into our lives, the data that trains these systems becomes even more critical. How might this increasing use of synthetic data change how we see real data and its value in the years to come? That's definitely something to think about.
For more deep dives into AI concepts and trends, don't forget to subscribe to the Before AGI podcast. And if you're looking for more hands-on tutorials and insights into the world of AI, check out my YouTube channel, Ian Okiang.
Oh,
Here you go. So.
until next time.